we found NREL, we watched what they were doing. They were taking silica and using it to store energy, and I already talked about that. But what they were doing is they were working on giant utility scale systems. And so what we did was we went back and forth with them and said, hey, while we're working on integrating processing into the giant system, and the US government is now going to build a pilot, pay for a pilot to build one of those. That's funded, and that'll be built in Denver. That'll be the first sort of commercial scale. It'll be a pilot, but it'll be a commercial scale system. That is already moving forward. We've now designed, I can show you, I was on a conference call with NREL scientists yesterday, and we have a deck that keeps growing with the work that they're doing. But all of the engineering diagrams, all of the equipment needs, everything has been identified for that system as well as another system. And the other system is something that we've been working specifically with NREL on, which is a unitized version of that. In other words, like a 1 megawatt times X. So if you want 10 megawatts of energy storage, you buy 10 units. If you want 20, you buy 20 units. But a really low OPEX, relatively low CAPEX versus equivalent lithium ion batteries, which are expensive. And this system doesn't light on fire on a regular basis. This system actually is very functional over a long period of time. To put this into context of a real world phenomenon, there's a company in California called Rondo. Rondo is currently using a refractory brick system. So where we use silica, they use refractory bricks. If you don't know what that is, look it up. Their refractory bricks are developed in Vietnam. Making refractory bricks is a greenhouse gas producing, it's worse than cement. And so they leave all of that environmental pollution in Vietnam, and then they take those finished bricks, they put them on a boat, and they send them to the United States and go, hey, we've got a clean and green system because we use refractory bricks inside of a container. So they put them inside a container, they have a heater, they have a cooler, and that system sells for a lot of money, and it sells into the commercial industrial space, companies that want energy storage plus heat. So a lot of industrial processes require heat. The best thing for a thermal energy storage system is a 50-50 split between energy storage and heat production. And there are a lot of companies. We've already been contacted by several companies, big name companies, who have come to us and said, hey, is your battery ready? Because we need it. And these are companies that service the food processing sectors. These are companies that service the pharmaceutical sector, et cetera, et cetera. There's a ton of industries that need this product. So from that perspective, we have that product. That company, Rondo, I think it's already $1 billion market cap. It's many hundreds of millions. They're raising tens of millions of dollars against their valuation. They're in commercial now. They're commercial, and they're selling that product. The distinction between the two is that they use the bricks, we use the silica. The economic distinction between those two is that refractory bricks are $2 to $4 a kilogram. My silica is 10 cents a kilogram. So you can figure that model out. We have a cheaper medium of energy storage. Everything else is really similar. We have a clean, green solution. Mother Nature created my silica. I just have to wash it. Mother Nature does not make refractory bricks. Vietnam makes refractory bricks by burning coal and producing greenhouse gases and disgusting waste material. So from that perspective, we are really green and clean. And we'll use that, obviously, in the marketing side. But that is ready to move into the commercial phase. So we've been working on that. We've identified the partners that need to come on board relative to that system. In other words, the equipment and the manufacturing of that. Will third-party manufacture that system? And so the idea is that we move that to commercial faster than the big systems that everybody has seen, where the silica will be processed inside the system at a utility industrial scale.